Welcome to another episode of Industry Insights. I'm Abhishek Kathuria, an assistant professor of information systems and the academic director of the Executive Fellow Program in Management. I have with me today Mr. Venkat Varadarajan, the Global Account Director for GSI at Intel Corporation. Welcome, Venkat. Thank you for being here. Venkat is an innovative leader in the field of technology with expertise in cloud computing solutions. He navigates at the intersection of business development and technology and delivers impactful solutions for clients in the digital era. Venkat, thank you for being here. Welcome.
Thank you, Abhishek. Nice to be here. Thank you for hosting me.
You currently work in the semiconductor industry. This industry has been in the news a lot in the past year, especially here in India. What are your thoughts on the state of the industry? Where is it now? Where is it headed?
Yeah. So, Abhishek, if you look at semiconductor as an industry, it is the foundation for any digital work that we do. As you know, the human life is getting more and more digitized, whether it is education or entertainment or shopping, everything is going digital. And all the digital transactions happen on a CPU or on a processor. So from that perspective, semiconductor is the foundation for any digital work we do or any digital transaction that we do. So semiconductor industry historically has been a cyclical industry. So it goes through these peaks and troughs periodically. And during COVID, there was extraordinary demand for laptops and gadgets, etc., because people were home and they were all working digitally. And coming off the COVID pandemic, we saw the demand coming down. So we are going through a phase where we are recouping the demand and coming back out of the demand slump. But having said that, our projection for the next 10 years is the industry is going to double from $500 billion is going to hit $1 trillion industry by 2030. That's our projection. In India, we see a secular growth of more than 18 to 20% for the next 10 years. That's our projection across laptops and servers, etc. So overall, I would say very positive, a lot of innovations, a lot of growth over a medium term.
Wonderful. Seems like things are very positive, very optimistic. So you mentioned a few things about how the semiconductor industry is fundamental to the digital revolution we're seeing around us. So thinking about this interdisciplinary collaboration, right? Look at the advancements in AI, cloud, data centers. Can you give some industry-wide examples that stand out in terms of groundbreaking innovations that are happening because of advances in the semiconductor industry?
Yeah, absolutely. So if you look at a semiconductor, a processor or a GPU, on its own, it can do nothing. So from that context, collaborating with other players in the industry is so important for a company like Intel or for any other player in the industry. So when we started the CPU, we had very deep collaboration with Microsoft. You know, the Intel combination, which is quite historic, right? So that way, like building on from the CPU and then having a software on top of that, OS on top of the database, SAP software, or containers, it's extremely important for any semiconductor company to work with ecosystem partners so that we deliver a value to the end customer or a end business. Otherwise, having a highly performing CPU with no ecosystem or no partners doesn't make any sense. So starting off from the PC era, we moved into a server era. And then back in 2003 or 4, we invented this technology called virtualization, where you can slice the server and then give it small instances across a data center. There the cloud boom started. From the cloud boom, then we are moving into the AI area. So each one of this is feeding into other. Starting from a CPU, you have the laptops to servers, and then you split the servers, create instances, and then you give it on rent across so many customers. It's called cloud. And then on the cloud, once you centralize, what happens is there is more and more software and data that goes into the cloud. So it becomes easier for organization to innovate on the cloud. So once we had the cloud era, the innovation really accelerated. So we have seen quite a bit of innovations across AI. We can talk about it all day long. And then there are like examples across the world. In India specifically, there are many innovations that stand out. Building on top of the UPI, companies like Paytm and PhonePe have revolutionized the digital transactions. First time in the world, the number of transactions, etc. Right, and then something more more closer to my heart is some of these startups using the cloud and AI to innovate on the healthcare sector. One example is a company called Niramai. What they do is they have a AI-based screening for breast cancer. Okay, as you know, screening for breast cancer is very intrusive. It's very painful. And what they have done is they have removed that painful experience using just images. More than human accuracy, they are able to detect breast cancer very early. Now their solution has been approved by FDA in the US. So these innovations really help the society at large across the world. So these are some of the innovation I can think of. AI is another big one. Gen AI, yeah, we all know about it. So it's a very exciting time to be in the technology area with respect to innovations.
Now let's take a step back, right? I want us to, I want you to just make your gaze a little more global. From a global perspective, within the semiconductor industry, how are companies integrating AI into their operations? Are there some trends or patterns that indicate that the role of AI within the industry will change? And again, I'm talking about this, or my question is more from a global perspective, across the globe, what you see.
Absolutely. So, like there's American saying, "Eat your own dog food," right? I mean, so we promote AI across the globe. Better we use it ourselves. So, from that perspective, yes, absolutely yes. There are many areas where we have applied AI internally. First example is we are a large manufacturing organization. We design our own chip, we manufacture. And Abhishek, each of the plant, we spend about $10 to $15 billion to set up a fabrication plant. And then there are AI in every part of those plant, whether it is the quality inspection, whether it is robotics, whether it is the supply chain, right? Every aspect of the manufacturing plant, we have deployed AI tremendously, and we are seeing huge improvement. The second aspect is supply chain. We have a supply chain that spans across the globe, and even our facilities are globally balanced. We have in US, Asia, we have in Europe, and we have in South America. So how do we optimize the supply chain from various suppliers? We apply AI there in terms of predicting demand, in terms of predicting supplier quality and turnaround time, etc. That is the second aspect. And third aspect is the whole pricing. As we were starting the conversation, I was telling you about how the industry is so cyclical and the supply and demand goes through these various cycles. So what we have done is over the past 1 year, we have applied AI to determine what will be the optimum price where we can have the maximum volume. Okay, that has between the supply chain, between the pricing, we are able to save more than $1.5 billion of savings by applying AI across supply chain and pricing. Only these two areas. I'm not talking about productivity improvements in the manufacturing plants. That's a whole separate area. These are areas where we apply AI in a day-to-day life within Intel. If we were to take a step back and then see how do we apply AI in chip design itself, right? So if you look at the modern chip design, we are going into something called chiplets, where there are like multiple small chips integrated in a package. Now, the power efficiency is an important factor, sustainability, etc. Right? So we need to save power at the PC level. So what we do is we have two sort of small chips or cores. One is the power-hungry core, and the other is economical core. Okay. So when your laptop is in a sleep mode or you're doing very light work, the economy mode kicks in. When you are throttling with a high-intensive game on your laptop, then your power-hungry core kicks in, right? Now, how do we allocate the task at the OS level to the power-hungry core and economical core? It's not hard-coded algorithm. It's AI-based prediction to say okay, this task is likely to consume more power. It is suited for economical core. This requires more performance, and hence it is required for power. Even at that level, where we allocate task at the individual CPU, we use AI. In chip design, we use AI. So everywhere AI we apply for effective productivity improvement and then technology enhancement.
So in sum, what you've said is you're using AI across the entire value chain and across
Absolutely.
the entire product life cycle, from chip design all the way down to production, and to determine what to produce where.
Yep.
Right. Fantastic. Let's switch gears a little. Let's change our gaze and talk about a topic that is of mutual interest. You're passionate about cloud computing,
Absolutely.
and cloud has changed the way businesses function in the past 20 years. And industries are converging. And as industries converge, cloud is serving as an enabler, not just in the semiconductor industry, but across diverse sectors.
Absolutely.
Can you shed some insights on how cloud technologies are reshaping the landscape
Yeah.
on a broader scale, in terms of information systems, in terms of data storage, in terms of compute on demand?
Yeah.
What are your insights on this?
Yeah. So about 5-6 years back, when the whole cloud revolution started, people used to talk about cost as advantage, because you use only, it's like pay as you go. You like use for 15 minutes, you pay for 15 minutes, right? But the other important aspect that people are realizing now is the whole innovation and time to market, right? So if you take a step back, Abhishek, 10 years back, you want to start a company, right? And you have to order a couple of servers, right? The servers will take 6 weeks to come, okay? 6 weeks to come. And then there is unpacking, installation. Once you install server, you have to install a OS on top of that. You have to install security patches. You have to install application software. The whole cycle takes 3 months, right? With cloud, you go click, within a minute, your instance is up and running. You can do whatever you want. You can develop an application, do a POC, and you can show your POC to your customers across the globe. So the kind of improvement it has given in terms of time to market is extraordinary. That people tend to underestimate. I want to bring that point up front. And then second, as we were talking about cloud being a centralized universe, a lot more data tends to get converged there. So data begets more data, right? So then it becomes a huge repository that people can run these training models, do analytics, and then get best insights. So that is another aspect that we have a like ready-made software available in the marketplace, and people can experiment, data available, right? And then the third aspect is, if you flip the question and then take from a supplier point of view, okay? Like late 90s, if you have a software company, right, and you have to go and install it, you are acquiring a customer in Indonesia, okay? You have to send a team of 6 people. They will go, take 6 weeks to install, roll out. Now what is happening? You have Freshworks based in Chennai and onboarding customers in Mexico to Africa to anywhere. The software is on the cloud. People can consume it as a service. So even from a supplier point of view, software supplier point of view, everything has turned into as a service, right? The third aspect that you were asking, how it has changed the landscape. Today, you walk into any enterprise, even the public sector enterprises, which were slow to start off, but they adopted to a large extent now. There is quite a bit of cloud adoption across HR applications, payroll, email, of course, Teams, the collaboration software. Almost, I would say, 60 to 70% of the enterprise IT has already gone onto the cloud, right? There are only maybe very few applications which customers are very sensitive about, or there is a regulatory requirement that it should not go. Only those are remaining on-prem. So that is where it is very, very exciting, and cloud has enabled innovation. If you are a startup, and every other startup today is starting on public cloud. Any of the unicorn you take, from Nykaa to Ola to any of the famous Indian unicorn has started grown on public cloud.
Absolutely. I'm just, segueing back into one of the things you mentioned about data being on the cloud. My own work, by the way, also shows that with data being on the cloud, it's much easier to collaborate
Absolutely.
across
Yes.
organizations, right?
Yes.
Because olden days, you would have to figure out how to transfer information or data. Now, with all the data on the cloud, it's just a click of a button, and you can share information across the supply chain with your value chain partners, increase agility, increase responsiveness, both within and across and beyond firm boundaries.
Yep.
Right. Right. Interconnectedness of technology ecosystems. So while cloud forms the basis of technology ecosystems getting interconnected, you've got the semiconductor industry. The other thing we're seeing in terms of a lot of growth in the past few years is data security and privacy concerns.
Yep.
What are industry wide approaches being taken to address concerns related to data security, privacy, cybersecurity?
Yeah. So the approach to cybersecurity within cloud has been the the shared learning, right? Like companies do share the threat information, and then the because cloud is centralized, it's more secure because you get to learn from many of the other threat and many of the other incidents. The um, the earlier thought that cloud is not as secure as on-prem is not valid anymore, because the software there tend to get updated more real time than what you have in your on-prem system. That way, the cybersecurity firms have made tremendous progress in terms of preventing attacks and quickly reverting if there is a incident. Apart from cloud, right, the rise of independent cybersecurity firms has been a phenomenon that we have seen in the past 3 years. You can have the names like Palo Alto, Sentinel One, and CrowdStrike. These are the companies doing exceedingly well. Um, the um, the reason being, beyond the security offered by the public cloud providers, you need additional layers of intelligence and additional layers of software capability that you have on the threat perimeter, as they call, right? So that way, things have become more secure, I should say. The Now, the newest trend that I was reading was applying AI to cybersecurity, in terms of you simulate various cyber attacks using AI, and then you have a proactive the remediation possible even before the attack happens, right? So um, simulating and creating scenarios using like AI on multiple attack fronts is the newest area, and that only makes security even more solid, I should say.
Are there any standards or best practices that industries are following for cybersecurity or privacy concerns, especially?
Yeah, privacy concern. Yeah, like you have the privacy concern has become more and more regionalized. There are sovereign specific data protection laws, whether it's Europe or India has its own law now, right? So yeah, most of it is based on the European principles, that if you collect data, you let them know that you're collecting the data, and then give them the option what to collect, what not to collect, and like inform them where it is stored, how long it is stored, and then the right to forget, right? In how, like, after how many years the data goes away, right? And that's also very, very important. So yeah, I think those are some of the best practices, and it's a like evolving field with a very high growth potential for the next 10 years. Very, very similar to semiconductor industry, I should say.
I like the fact that you picked up on this. That you mentioned the notion of the right to forget. I like to say in my classes that there has to be forgiveness in the digital world, right?
Absolutely, yeah.
Unfortunately, our digital footprints remain there forever. The internet does not forget, so there's not enough forgiveness, right?
Absolutely, you said it very well. The person XYZ commits a small mistake, he gets the punishment. After the punishment, he should be like any other citizen, because his punishment is over, and he is a citizen as like any one of us. But internet does not forget. You do a search, it appears. So which is very wrong in my view.
All right, for a final question, let's take a step back further and I'd ask you to put your gaze beyond the horizon. So far, we've talked about what's happened in the recent past, what's happening in present, and maybe the immediate future. But let's look at the horizon now. Beyond these advancements in AI and cloud, what do you see? What emerging technologies do you see on the horizon that can further catalyze the convergence of innovation ecosystems?
Yeah.
And how would these technologies impact the semiconductor industry and the relationships of your industry with other sectors?
Yeah, yeah. So the one trend that we clearly see for the next 3 to 5 years, medium term, is the emergence of the edge, as we call, the edge computing. So Abhishek, what is happening is the whole 2010s leading up to the pandemic, we had a boom on the cloud, right? More and more applications were going on to cloud. Now that is entering into a mature growth phase, right? With the advent of 5G, and we see lot many devices and things in the edge that can do small processing, that can have small intelligence, etc. That is one very clear trend that we see. Again, it will go through the peaks and troughs as you see in any industry, but over a medium term, we see a secular growth, primarily enabled by 5G. And one example I can give is autonomous car, right? And if you look at the autonomous car, as the car navigates once in 15 kilometers, it connects to the next cell phone tower, and then it gets the real-time data in terms of traffic, in terms of any other alerts, etc. Right? At the same time, for immediate action like learn switching or stop, it has to do its own intelligence, right? So we see car as a powerful computer. It has to do its own processing, immediate action. At the same time, it has to communicate constantly with the cloud. So this is a classic example where the cloud exists and the edge also exists, and both do their duty, collaborate seamlessly for the benefit of customers, right? So similarly, the use of edge on the industrial scale, like manufacturing, is well documented. The robots on the shop floor, we already have. The Kia factory in Andhra Pradesh has one of the largest number of robots on the shop floor in India. And things, sensors, which is there across the railway stations and your airports, public places, that will continue to evolve. Like right now, a camera might be only recording, but after a few years, you will see the camera becoming smart camera. It can do inferencing, and at some point, you will see it can also do small training and then have a quick model ready, right? So like more and more processing, more and more compute going into the edge is a secular trend that we see. And of course, AI is another area, very, very impactful in terms of productivity, in terms of innovation, etc. We will continue to see a good growth. And then from our own industry perspective, quantum computing is an area where I hope to see, at least before I retire by 2030 or so, it should come to the mainstream. We see some early green shoots, like IBM has done some work, and there are some startups in quantum computing, but is not in the mainstream area yet. But once quantum computing hits the mainstream, you will see enormous improvement in computing capacity.
Power to the edge. I think that's the key thing
Yes.
that we're talking about. Over the next 5 to 8 to 10 years, there'll be more power to the edge enabled by 5G. There'll be more fog computing.
Yep.
As quantum computing comes in, you're going to rapidly see a decrease in cost and power. So the rise of autonomous agents all around us taking autonomous decisions, not just AI-based software agents, but hardware agents with AI built into them that'll be able to take decisions. I think we're looking at a very exciting future, not just for technology enthusiasts like ourselves, but for humanity in general at the larger level, for businesses, and particularly for the semiconductor industry, because as you've said beginning, the semiconductor industry will power all of this.
Absolutely.
The brains behind each one of these devices that is going to be all around us is going to be produced by the semiconductor industry. Thank you so much for your insights. This is very insightful and very helpful. I'm sure our viewers have enjoyed this. So thank you very much for joining Industry Insights.
Thank you, Abhishek. It was a pleasure talking to you. I enjoyed my conversation. I hope the audience find it useful. Thanks a lot once again.
Thank you.